Welcome back to my channel. Today we're going to work on the question, sort array by parity. It's an easy level question. The question states, given an integer array nums, move all the even integers at the beginning of the array followed by all the odd integers. Return any array that satisfies this condition. So for example, if our list nums is 3, 1, 2, 4, want to move the even numbers 2, 4 to the front and the odd numbers 3 and 1 to the back. And the outputs 4, 2, 3, 1, 2, 4, 1, 3, 4, 2, 1, 3 would also be accepted. So the order doesn't really matter as long as all the even numbers are at the front and odd numbers are at the back. So looking at this question, I can think of 3 ways to do this. Let me go through each of the ways. The first way is using list comprehension. And the second way is using using an additional list with insert and append. And the third way is using 2 pointers, which is going to be 1 pass. And for the first two, both time complexities are, for time it's on and space is also on for both of these. The last one, the time, because it's 1 pass, the time is on and the space will just be O1 because we won't be using additional space. We'll just we'll just change it on the original list, which is nums. So let me go ahead and start my solution for these 3. So for the first one, for list comprehension, we can have an odd list. Let's start with even, an even list, which is x for x and nums if x modulo 2 equals 0, and then we can have an odd one, x for x and nums if x modulo 2 equals 1. So, and then we just have to return even plus odd. As you can see, time complexity 200 milliseconds, 14.7. Time is on and space is also additional space on, odd plus even is the original length of nums. So let's go ahead and do our second solution. So our second solution is just using additional list. Let's have an output list equals this, and then we go through our nums and we'll insert, let me write it first, for n nums if n modulo 2 is an even number with no residue. It means it's divisible by 2, which means it's an even number. Then we can nums.insert. At the 0's position, we insert n. And then if n modulo 2, or we can just do else we can do nums.append n. So else it would just be all the odd numbers. And then in the end we just, sorry, not nums, output. In the end we just return our output. And as you can see, this is the solution is also on time and then on space because we use additional list for our output. Compared to the first one, using list comprehension, it's like 4 milliseconds faster. Space is around the same. And let's do our last, which is the best complexity solution in terms of these 3, the 2 pointer solution. So I'm going to have a left and right pointer. The left pointer is going to start at 0. The right pointer is going to be the length of the nums minus 1 at the very end of the last element in the array, basically. So while left is smaller than right, then and we can check if nums left modulo 2 is greater than nums right modulo 2. Basically, this means the left one is an odd number and the right one is an even number, because odd is always equal to 1 and even is always equal to 0, and that means we want to switch the two. So then we would do in-place switching, which is nums left, nums right equals nums right, nums left. And then otherwise, if they're normal, like if nums left divided by 2 equals 0, if it's already even, we just increase our pointer by 1. Same thing with our right pointer of nums right modulo 2 equals 1, then we just decrease our right pointer. And then in the end, we just return the original array, which is nums. Yeah, so the solution is supposed to be the best one pass. The time complexity for this one is O(n). We only go through the list once, and then space is O(1). Thank you so much for watching, and let me know if you have any questions.